Hi all, welcome to day 17 of our 100 days of DevOps journey. So let's get started. First of all, let's have a little recap of our previous 4 or 5 days, okay, or this week currently. So what we have learned about, there is this Docker, okay. Docker is basically the containerization from the very beginning. Let's just say I'll just add some kind of either text, okay. Just a moment. Okay, this is the text field. So first of all, let's begin from very starting. What we have learned in this. Okay. So first thing first, what is containerization? We have seen that. Okay. Containerization. So containerization is basically virtualization of OS. Okay, virtualization of OS, operating system. Okay, we have seen that. So containerization, what we use for containerization, we use Docker. Okay, Docker creates containers. Okay, on top of Docker, we can create containers. So we have seen like what is Docker, how are its component working. Okay, we have understood about Docker network, Docker. First of all, Docker containers we have understood about. So what are main components of containerization? First of all is the container, Docker container. Okay, then we have network, because unless you can't reach to your containerized application, there would be no use of it. Okay, so networking we have seen persistent volumes or persistent storage. So, and lastly, we have seen yesterday Docker images. Okay, everything is created under this one. So there are a lot of things in this. I have taken up Docker. We have also previous that we have seen Git, some Linux command, and yeah. So this is, I think this much comprises on everything. Let me just, so Control R as such. Okay. So here we are in our machine, RVM. Okay, I'll just increase the font, and we have Docker vs-a. No containers are running right now, and Docker volumes might be available because we have created some on that day. So these are the volumes. Yeah, I'll just create Docker RM, or we can use this volume for okay, let me just remove it. Let's clean the set. Volume RM Docker. Okay, so no volumes are currently available, and there is Docker images. Mm. So these are some of the images that we have created yesterday. Okay, so I'll just Docker RMI is command, or we can say image RM. Okay, -f. So right now, before deleting it, here you can see the size of each of these image. Okay, it is quite large here. On this particular image we have started building on top of it, then this then the size was getting increased. Okay, size was getting increased. So here what is we'll discuss some of the best practices today as well for containerization or containerized application. So let's do that. So here, so where all these images are getting stored, what is the location where we have, there is this df-ht, right? H df-h. So here, this is the n slash where is slash directory. Yeah, this is the slash directory. So currently available is 15. Okay, now there is total 24 GB of drive is allocated, amongst which 7 GB is consumed. Okay, and if you can see over here, dev, so storage in the systems are very limited. If you are getting your images are getting compiled over here. Okay, so there might be someday that you have to delete, or your storage get full. So there are container registries. Okay, remote container registries on which we can if I'll just open my yesterday, save it. We have, yes, day 16. Okay, yesterday we have created this container image. So container image might get piled up. There are a lot of image, and every time you make changes, you create a new version of this container image, or you download a new version. So sometimes what happen, it will consume all of your storage. So for that reason, what we do here is, I just copy this particular data. This is the data, and here this container image is used to create the container. Okay, but sometimes there is this storage issue we get. So what we can do here is, we can, over a particular network, we can create a particular we can create a registry. Okay, or yeah. So there are two ways to save your container. First of all, let me just show you one thing. So how are container images built? Like in ISO, if you have opened the ISO, okay, if you have opened any particular ISO of like I might have some. Oh, there is. If we mount a particular CD, we can see the data on that. Let me just check if I can. If we mount this particular ISO right now, I can't see over here. So there are certain number of, yesterday we have seen there is this recipe. Okay, we have recipe and we have ingredients in a particular image file. There are two things. First is recipe, and second one are the ingredients of that particular container. So let's see, how can we check that? CD, oh sorry, sudo -i here. Okay. CD slash not etc slash not where lib docker. We have image overlay distribution. Hmm. So these are, if you can see over here, so these are the image layers. Okay, if I just show you docker images, so here you can see this particular image over here. Okay, uh yeah, this is the particular image. So if I just go into this, these are, I think, the hash files, or ls hyphen. These are the files. Cat. So here you can see it is in JSON format, architecture, AMD6, configuration, host, and everything. So this is the recipe. Okay, this is the recipe of that particular container image. Yeah, till here. I just copy it, and there are online tools for JSON formatter or something like that. Okay, so in right side you can see, in the right you can see. So what do we have? It has architecture. There is this config file, host name, domain name, user. There is attach standard in, standard out, standard error, TTY false. So everything is over here. So this is like the recipe. Okay, recipe of that file. Now let's check over the ingredients part. Okay, ImageDB content, metadata. Okay, so these are the directory, and similarly, like we have seen this particular file, there is this metadata ff. Where are the, this is the Ubuntu machine. If you remember this, I think we have here. So parent is this particular machine, and docker lib overlay is so messed up right now. Let's clear it. So right now this particular name is very large directory name. So how can we shorten it? Here is also one trick we can use. So what terminal like what terminal we are using right now? Okay, so there is one like echo shell. Yeah, bin bash. Okay, this bin bash is our shell. So for bash, this bin bash, we have one file. I think it is in nano, or yes, first of all ls/etc bash bash.bashrc. Okay, this file. Let me just get. Okay, here are some of if you can see over here. First of all, let me open it in nano /etc bash.bashrc. be in editor mode. Now we are in editor mode. So here there is one. So this PS1, if you are if you are able to see over here, this PS1, okay. So this PS1 is responsible for this shell path, okay, this prompt length. So how can we do that? There is one trick over here. So here, if you can see, I'll just explain you. This Debian chroot plus Debian chroot. Either this here this is user at the rate host, okay, user at the host, and there is this working directory. Set the fancy prompt non-color override or everything. It has so many things over here. So this path, this particular PS1 here, you can see. So this is responsible for your prompt length. So if sudo user, then this sudo user. So sudo user is root. I'll just make a little change over here. Insert. Oh no, what is happening? Already. Like first, let me comment it out. It is commented, right? S1 equal to. We'll just add one thing. I might crash my terminal, so let's just see what will happen. Okay, host, and we have working directory, right? Slash current working directory. So here, if you can see, it is small. Okay, this one is small, so it will show the whole working directory. But what I want here is I want only the current working directory. And this is the shell. I think this will suffice. Control X, Y, enter. Exec bash. What is happening? It is still not running. Or what? Try one more thing. I think this source. Yeah, now it is shortened. Okay, so here it is showing the current directory. In fact, we can shorten it even more if we don't want to use not even the current directory we want. So there is here we can use it like this. So source was the command. So yeah, now it is much better. Great. So let's just begin. Okay, if we run pwd, it will show you the complete command. Okay, I'll change it back to its original form. So it is just for showing you how to use it. Let's go back. Where are we? Yeah, we were in this particular file. So there is parent, there is this cat, last update date we have. There is one more thing that we can check over here. ls content, we have checked cat content shafe. So fe is a file, we have checked this. LayerDB distributions, LayerDB cat repositories.json. So Luffy, we have again, let's copy this for copy this output over here and paste it over here. Okay, we have Luffy, we have yeah, here you can see like what is the hash value of this file. Okay, and here for Ubuntu, I think Ubuntu is there. Yeah, so Ubuntu, we have this is the file, and SHA of that file. So it is, since it is verified, so we have to keep it like that way. Hash value Ubuntu latest and ls, and then distributions we have check ls distribution diff by digest or ls-l layer db mounts total. What is that? Total 0. Nothing else in mounts. Nothing in. They are all directories. F3 cache parent size. Let's see. the star split json.gz. For human readable terms, you can use it. So size is, these are all the files. This is a tar file. Then let's just check get sha fe. We have parent. Different hash value cache id. So these are some of the interesting things over here. You can anytime use them. So what is let's just reconvene on that. What is the an image? What does the purpose of an image serves here is, an image is a set of like, it has the recipe as well as the ingredients to create a container image, to create a container. Okay, just similar to the this file. I'll just go to source. Yeah, now we are in correct location. Okay, distribution layer db image. So suppose if right now what is happening over here is we are saving this file. Okay, I'll just show you one more step. Docker images. Docker images we have here. So suppose if I have to save this particular file, okay, this Luffy Mugiwara, this particular. So there is one more thing, Docker image hyphen h. Here build history, import the content from a tarball to create file system image. So like you have seen this tar zip file, okay, we can create a zip file from the image as well. So that right now this image, this container image is not we are not capable to store it in some kind of we can store it, but there might be chance because there are multiple hash values there and everything, metadata and everything. So there might be chance if we store this image like in this open format in like git repos in git repo. Okay, git repo. So sometimes it might cause us trouble. So there is very important way. It is called save. This save one or image in a tar archive format. Okay, stream to std. So let's just docker image save. Which image do we want to save over here is like let's just say Luffy. Luffy. Let's check the hell. Docker image save option and image. Option output. Yeah. Hyphen o in output file. Which file do I want to save? Luffy Mugiwara dot tar. Keep it tar. Okay. And this is the file. And yeah, Luffy hyphen docker image save docker save. Write to file. Write to a file instead of send. Let me just check this. Mhm. So what will happen, this particular image is saved in this file, if you can see. So this particular file. Okay, and let's just docker rmi. I'm deleting all the images. Okay, docker rmi hyphen a. Okay, docker images hyphen q means container this id. Okay, all the images are deleted. Docker images, right now no images are there available. Okay, no images are available. So how can we now we have this file Mugiwara tar. Okay, docker image hyphen h. So there is one more import content from a tarball. So this import file, okay, this import can be used to convert this tarball image into that file. So let's just check docker image import. Here import means import help change apply docker file instruction to create an image to set message for imported images. Docker image import message for imported images platform set platform. Okay, so no worries with that. We already have everything. Here is the file retro Luffy and okay. So now let's just check docker images. I haven't pulled it. Okay, I haven't pulled any images right now. In fact, I can show you the history as well. Okay, so here docker image import and docker image here, and you can see docker images. So here this particular, so it has retained only this part, only this thing. So how can we do that? Docker tag, this is one more command, docker tag. So docker tag source image, so we need to copy this image id. Okay, docker tag and Luffy Mugiwara. Okay, if I just check, so the same image that we have created, it has got a repo name and tag available. There is one more option. I think I forget that in import itself we can change list, apply docker file, set platform, commit, set commit message for import yeah, in here itself we can use this import like Luffy Mugiwara and I guess so, Luffy straw hat. Okay, so if I just check, oh yeah, it has created, but what it has changed the hash value since we have added the name over here. It should not be changed, by the way. I think I'm forgetting something. Docker image import option, file URL or repo tag. That is fine. I think everything mentioned over here. Let's try one more. Valid reference format. Okay, I think there is this we can do. So right now I'll just RMI. Oh, not RMI. Here. Suppose let's just say there are multiple images or multiple versions that I have to create, okay, of this particular image. So I cannot store it in my system for long. Suppose if my system gets storage get full, I have to delete it, or sometimes the storage gets crashed. Okay, so how can I save that? So there is one thing that we can use over here. It's called repository or container registry, we say. Okay, okay, so here this is the repository or container. Or most commonly known as registry, container registry. Okay, a container repository or container registry. So what we can do here is we can just save this file to this container registry. Okay, and whenever required, we can just easily download it or upload our images. So it has capabilities to manage the version itself. So if like it can be in a network, okay, in a storage network, or it can be over the internet. So some of the common registries are, so there are two types of registries, public and private. Like here we have seen so many examples like Docker Hub. We have, okay, Docker Hub, okay, hub.docker.com. So it is a free container registry, container image library, or container registry, container repository, you say. Okay. Then there is we have quay.io. It is also a container registry, but it is managed by Red Hat. Okay, Red Hat quay.io. So here also you can find like MySQL. If I search, try for free on cloud, build, analyze, distribute your container images. Here Docker registry you have. So there are tons of registries like available. Machine learning registry, TensorFlow, PyTorch, LangChain, Llama. Okay, then there is Memcache, Nginx, most pulled libraries. Busybox is mostly for testing. Alpine, Postgres database storage, Neo4j, MongoDB. So there are a lot of like Grafana we have, Telegraph, InfluxDB. Okay, a lot of libraries are available. Okay, a lot of repositories are available. So what we'll do, first of all, to update like here for to upload our repository, it is a dynamic repository. You cannot share your repository on that. And there are some other container registries available, like cloud native container registries in AWS provides this ECR, Elastic Container Registry, and container registries. So there are Red Hat popular container registries are like Docker Hub, and Docker Hub is the most common one. Then there are we have Quay.io I have shown, and these are JFrog. In fact, GitHub also provides GitHub container registry. GitHub also provides working with container registry. GitHub package, GitHub container registry. Yeah, here is this the one? Awesome Harbor container registry. So JFrog is open source registry. You can configure your own registry in. It is for JFrog is artifactory. We can say artifact. Multiple types of artifacts are like packages. Okay, packages, binary files, and everything. JFrog is used for that. Then there is Nexus. Okay, Nexus artifactory. So these are some common artifactory. Let's just use our like Docker Hub. Okay, let's just go to Docker Hub. I need to create one account with this. So what I'll do is I'll just create a temporary account. Temp mail. Let's see. Okay. Here username. Continue. I just create some random password. Use 4 to 30 characters. Okay, and digits only. Okay, I think. I set up. Yes, copy this. So I think I have to activate verify email address. Now I think I would be able to. Okay. Yeah, so I am logged in right now. Okay, this Boolean. So how can we upload one of the, so it has create container registry. Create container registry. So what we have to do over here is this. Let's create repository name Luffy. Okay, there are two options, public and private. So private, unless you have logged in through this particular account or any associated account. Okay, or there are enterprise account or business accounts. Okay, organization accounts. So using zero of private repository. So unless you can download it, unless you have, if you have kept it public, anyone can download, anyone can pull this repo. And if you haven't kept it, you have kept it private. So unless you have logged into this particular account, okay, there is one command that is called docker login. So unless you have done that, you wouldn't be able to pull this repository or even see this repository. So what I'll do here is I'll just create it repo. Okay, and I'll push this particular. So let me just try it once on Docker images. I just said Docker push. Oh, I already have copied it. Okay, no worries. Docker push, and when we have straw hat or push it. So the push refer repository, this an image does not exist locally. Okay. That is because this we have to tag here like that. docker tag Luffy Mugiwara. Luffy Mugiwara. Okay, docker images. Here we have this particular file. Now let's just try to push it again. Denied request access. Okay, it has been denied. Why so? Because we do not have there is this particular method docker login. Okay, so in this you can add username. What's my username? This is my username, and here is my password. Login succeed. Now let's just try to push image again. So just keep in mind this particular tag. Okay, this particular image. This is the image ID. So let's copy this. Pushed. Okay, push is completed. Yeah, push complete. Push is completed. So let's just refresh it. Yeah, here we have. So a few seconds ago it is saying OS Linux and it is container image pulled 0 times. So layers are, oh yeah, we have vulnerabilities. Right now we have to update it. So here you can see the size. It is compressed size. Okay, it since we have created it using the Ubuntu machine, Ubuntu image, which is already available on Docker Hub. So it is using that cache, that it is saving that cache only. Okay, here if you can see this manifest digest, there are one more thing. Yeah, this is layer tag. This is the digest tag. Uh, just a moment. So I think let's halt here. Let's so this is all for container registry, and there are public registry like Ubuntu and others that uh, we are downloading frequently. So thank you all. Let's reconvene tomorrow on day 18 of our DevOps journey. So thank you all. Have a nice day. We are in login part. What is sign up email?